This is the second part on the chapter on similarity. From exercise 15C, question number 11. In triangle ABC, right angled at A, AD is drawn such that angle DAB is equal to angle BCA. If BD is 24 cm and DC is 3 cm, find AB. Let's go back to the question. In triangle ABC, this is the figure given. ABC is the triangle. In this triangle, which is right angled at A, the angle here is 90 degrees. The whole thing is 90 degrees. AD is drawn such that this line AD is drawn such that DAB, angle DAB, can you see this single arc marking? That one. And angle BCA, that's this one. These two angles are equal. That's why this is marked with the single arc, this is also marked with the single arc. We can mark it again with red. That's single arc, and that's also single arc. These two angles are equal. And it says if BD is 24, B to D is 24, and D to C is 3, DC is 3. You have to find AB, this length, you have to find AB. If you look at this figure, you will see there are three triangles. One is the biggest one, ABC. The second one is the smallest one here, that's ABD. The third one is ABC. Three triangles are there, but you have to prove that only two triangles are similar. Okay. For that, look at the question. You have to find what? Find AB. AB is the side of the biggest triangle and AB is the side of the smaller triangle. So this is not involved at all, this one. Okay. AB is the side of the biggest triangle, that one. Okay. ABC. AB is the side of ABC, and AB, this side, is also the side of triangle ABD. Okay. Because you have to find AB, you can find which two triangles you are going to take. So I showed you which are the two triangles. Now, if this was not asked, something else was asked, still, which are the two triangles that you are going to take is, look at this. Can you see this angle marking? This angle marking, okay, is an angle in the biggest triangle, that is ABC, and this angle marking, which is same as this, is angle of ABD. Therefore, the two triangles that you are going to prove to be similar are ABC and ABD. Okay. To know that which two triangles you are going to use, if there are three triangles, always take the biggest one first and one of the smallest one. Now, these are the two triangles that you are going to prove to be similar. You already know that this angle and this angle are same. You have to also find one more angle which is same in both. Okay. So the angle which is same in both, that is in triangle ABC and triangle ABD, is angle B, this one. Check. The one with the double arc, this angle is present in ABC. It's also present in ABD. So this becomes a common angle which is there in both the triangles. So two angles are equal, therefore these two triangles are similar. So in triangle ABD, the smallest one, and triangle ABC, the biggest one. First one, let's write about the single arc ones, this and this. This you have to name, this is angle A, but you have to name with three alphabets. So BAD, that is this one, angle BAD or DAB is equal to this one you have named, okay, that is angle BCA. Now why they were equal is it was already given here. Okay, so that's why I have written given. The second angle was this one with the double arc. In the smallest one, the double arc is ABD, that's angle ABD, is equal to the second angle here with the double arc for the bigger triangle is angle ABC. This one is angle ABC. Now how these two angles are equal with the one which is marked with the double arc is because they are common. So two corresponding angles are equal, therefore these two triangles are similar. Therefore triangle ABD is similar to triangle ABC. By what property? You can see the angle marking, therefore angle property. Once you know that these two triangles are similar, then you can write this. Since the two triangles are similar, their corresponding sides are in proportion. Now, before writing the proportionality, you have to draw the two triangles separately. So what I have done is I have drawn the two triangles, normally two triangles. No need to draw one small, one big. Okay. Just draw two normal triangles. Name the first one. That is, the smallest one is ABD. ABD. Is A marked with any angle? That's a single arc. So let's mark that one. It's a single arc. And B is marked with a double arc. Do the same angle marking here. Don't name it. Do the same angle marking here. Single arc is on top. Double arc is here. Now look at the biggest triangle and name accordingly. What is marked with the single arc is C. What is marked with the double arc is B. Therefore, the third vertex is A. Now both look the same. It's easy to find which are the corresponding sides. Corresponding sides are AB and BC are corresponding. AD and AC are corresponding. BD and AB are corresponding. Once you know this, now write the proportionality looking at these two figures. So the proportionality is AB by BC is equal to AD by AC is equal to BD by AB. Okay. Always write these sides according to alphabetical order, then it's easier. I could have written BA, but write it according to alphabetical order. A first, then B. Okay. Now, the question was, if this is 24 and this is 3, okay, find AD, it says. BD is 24. Let's mark that here. BD is 24. Okay. B to D is 24. That much is 24. And D to C is 3. DC is not here. Okay. DC is not there at all. But B to C, the total length is 24 plus 3. That is 27. BC is 27. Okay. BC is here. That is 27. And you have to find the side AB. Okay. Now if you look at this proportionality, you have to find AB. Okay. So AB is what we are going to find. So AB is here. AB is also here. So you have to use both these ratios because AB is present in both. Now with AB, what is there? BC. Check whether you know BC. BC is 27, is known. With AB, there is BD. BD is also known, which is 24. Okay. So this and this ratio I am going to take, leave this one. So AB by BC is equal to BD by AB. AB is what we are going to find, this and this. Okay. So keep AB as it is. So AB into AB becomes AB square is equal to BD goes that side into BC. So AB squared is equal to BD's value. BD's value we already know. BD is 24. BD is 24. BC is 27. Okay. So if you have to find AB, you have to find square root of this. Now to find square root of this, it's better to write the factors of 24 and 27. Start dividing 24 by 2, you will get 12. Divide by 2, you will get 6. Divide this by 2, you will get 3. That 3 is here. 27 factors are 3 into 3 into 3. We are finding square root, therefore pair them up. These 3 is together, this 3 is together, these 2's are together, this is single. So even after taking square root, this will still remain under the root. So this will become 2, this will become 3, this will become 3 after finding square root. 3 into 3 is 9, 2's are 18, and this remains under the root. So AB's value is 18 root 2 centimeter. Then, next question is from exercise 15A, question number 11. In this figure, AB, this one, is parallel to EF, is parallel to CD. These three lines are parallel to each other. EO is 4 centimeter, EO is 4 centimeter. This much is 4. AB is 12. AB is 12. OC is 8. O to C is 8. And DC is 16. D to C is 16. Calculate first subdivision EF. You find this much EF. And second subdivision you find AC. A to C, this whole length. First one you find EF. This is EF. Now you will have to consider a triangle having EF as one of the sides. Okay. So for that, the two triangles which I am going to consider are, let us shade the two triangles. Look at this. That one and the other one is this. The ones which I have shaded with red, two of them are triangles. The same thing I have drawn here. Okay. The rest of the figure I have not drawn. So this is EF, EF, in between there is a O, and that is DC, DC. DC is known, which is 16, this is 4, this is 8. Okay. Nothing else you know, you have to find EF. First, to find EF, prove that these two triangles are similar. So, to prove similarity, first mark the two angles to be equal. The two angles are, this angle is equal to this angle. It's like the previous one. This angle is equal to this angle. Okay. And the second one is, this one is equal to this one. Why? Because these two sides are parallel to each other. Okay. These two sides are parallel. Therefore, these two angles are called interior alternate angles. So two corresponding angles are equal, therefore these two triangles are similar. So first you have to write proof of similarity. We are doing the first part, finding EF. For that, in triangle EOF and triangle DOC. These are the two triangles we have taken. Let's first write about this angle and this angle, which are same. This angle in the first triangle is EOF. So angle EOF is equal to angle, this is angle DOC, the DOC. Why these two are equal is because they are vertically opposite angles. First one is done. Now let's write about the second one. This one is angle OEF, OEF, that's this one, is equal to, this one is OCD. Why these two are equal? Because they are interior alternate angles. Now two corresponding angles are equal, therefore the two triangles are similar. Therefore triangle EOF is similar to triangle DOC by what property you have tried? Angle property. Okay. Once you know that these two triangles are similar, then you can write their corresponding sides are in proportion. Since the two triangles are similar, their corresponding sides are in proportion. After writing this, immediately draw the two triangles separately. Normally draw two triangles. I have drawn two triangles here. Name the first one. The first one is OEF. OEF. Let's see what are the angles that are marked. O is marked with a single arc. E is marked with a double arc. Do the same angle markings here first without naming. Single arc on top. Double arc is here. Now look at the second one and name accordingly. Single arc is O. Double arc is C. Therefore, the third vertex should be D. Once this is done, now write the proportionality. Looking at these two figures. Okay. So, proportionality will be OE by OC is equal to OF by OD is equal to EF by CD. That's what is here. But the question was to find EF. This is what you are going to find. We are going to find EF. Which means you have to use this ratio. And you have to choose one of them, whichever is known. Let's look at our figure and see which two sides we know. OE, OC. OE, OC, both are known. So which means you have to use this ratio and this ratio. Leave away this. So, OE by OC is equal to EF by CD. I have left this one. OE is 4, OC is 8 is equal to EF is what we are going to find by CD's value was 16. You can simplify this now. 8 and 16 will go twice. Multiply the 2 here. That's 8 centimeter is the value of EF. That's the first part of the question. There is a second part of the question. which says calculate AC. Now if you look at this figure, this is the actual figure. AC is what we are trying, this one. And AC is the side of ABC, this one. So the two triangles that we are going to use, this is of no use now. You will take this triangle, the biggest one, and this triangle, which is the smallest one. So what I have done is I have drawn both of them separately. This one. This is our figure. This is the biggest one. This is the smallest one. This was 12. This was 8 we found just now. EF is 8. And this was 4 and 8 added together, that gives you 12. We want to check 4 and 8 was there. 4 and 8 together is 12. Okay. So that is what I marked here. So first you have to prove that, first see whether there are two triangles. The two triangles are ABC, biggest one, and the second one is EFC or CEF. Okay, is the second one. You have to prove that these two triangles are similar. For that, two angles you have to mark to be equal. These two are parallel, therefore this angle and this angle, this angle and this angle are equal. Why they are equal? This one and this one is they are corresponding angles, because these two sides are parallel. These two are corresponding angles. One more angle which you have to mark, we can mark this also. This and this are equal, they are also corresponding. Or the third one is this. This angle is present in the biggest one. This angle is also present in the smaller one. So that becomes a common angle. Okay. So the two triangles that we are going to use are in triangle CAB, biggest one, and CEF is the smallest one. First angle which is same, angle CAB, that's singular, must be equal to, which is the other single arc is CEF, this one. Why they are equal? They are corresponding angles. The second one is about this. For the biggest one, it is ACB, and for the smaller one, it is ECF. Why? This is same in both, is it's the common angle. So two corresponding angles are equal, therefore the two triangles are similar. Triangle CAB is similar to triangle CEF by AA property. Once you know that the two triangles are similar, their corresponding sides are in proportion. Since the two triangles are similar, their corresponding sides are in proportion. Now, what you have to do is draw the two triangles separately. I've just drawn two normal triangles. Name the biggest one. The biggest one is actually CAB. Okay. Now, is C marked with anything? C is marked with a double arc. Is A marked with anything? A is marked with a single arc. Do the same angle marking here, a double arc and a single arc. Now look at the smaller one and tell me which is the one which is marked with double arc is C. Single arc in the smaller one is E. Therefore the third vertex must be F. Now the sides which you know, AB is 12, AB is 12, EF is 8, EF is 8, and EC is 12. EC is 12. Question was to find AB. Okay. You have to find, sorry, the question was to find AC. This is what you're going to find, AC. Now, you've drawn the two triangles separately, right? Proportionality. AC by CE is equal to BC by CF is equal to AB by EF. AC is what we are going to find, so we have to use this ratio. We have to use this ratio. And out of these two, you have to see which one is known. Is BC known? B to C. BC is not known. So we cannot use this. Is AB known? AB is known. EF is also known. So this is the ratio that you are going to take. These two ratios are written here. Okay. AC is what we are going to find. CE's value, CE is 12, is equal to AB's value is also 12 by EF is 8. So AC is equal to, this 12 goes there, 12 into 12 divided by 8. Simplify this. Both these can be divided by 4, twice, thrice. this and this go 6 times 6 into 3 is 18 centimeter is the value of AC. That's the second part. And your homework is from exercise 15C, question numbers 4, 7, 40 subdivision 1 and 40 subdivision 2, and from exercise 15A, question numbers 1, 19 and 17.